Hello everyone, welcome back. In this part of the video, we will basically try to copy um, the script that we made, the definition that we make for our major helix or outer helix, and try to adapt that to the inner helix. As you may have noticed, I only changed the color of the deck I-beams a little bit because it was previously blue, and blue with blue just didn't really make any sense. So that's the only change I made after uh, in between the videos basically. So let's start looking at what we need for our inner helix. Actually, let's give it a name already. Uh, let's copy the name of this one and then just call this outer helix, something like that. There we go. We can start by copying the whole script and then just modifying as we go and see what we need to modify. So let's select all of it, drag, press Alt, hold down the Alt, and release. And then we can name this inner helix. Okay, let's see. We have a main curve, which we have a length, section width, so these are going to be the same. Outer helix diameter, this is what we're going to be changing to the inner helix. Now, if you if you didn't know, there's a trick to easily replace all the connection. So if you hold down Control Shift and drag the output of this component, you can actually replace it all to a different component. So now that we've done that, you can see already on the screen. Let's change the color so we can identify it a lot more easily. I'm trying to go for, I don't really have a nice color to go for actually now. The screen is horrible. Okay, you know what? Let's just go for this light salmon-ish color. We might have to change it to a different one too. Make it more pleasing for us. Let's change to a dark bluish purple. Anyway, so we were here, we changed that. Number of outer helixes. Well, this is also different. Number of outer helixes. Do we even need that though? Mm. Oh, but that's to define the number of the circle that will be divided. So we might have to keep that. Distance between the helixes is 4. It's still 4 for the same thing. The diameter of the tube is also the same. So that part is okay. And then we have a line that, aha. See, the circle is now different, I believe. Yeah, 4.7 because we are now using the inner helix. But there's actually a problem here. Because if we look, maybe I can use the front view. Let's change this to rendered. The problem is that the diameter of the inner helix is actually not 9.4, and I'll show you in a second why that is. Maybe I can show you with the photographs here. Okay, doesn't seem like I can show you, but what I'm trying to say is if I can draw the same helix again, if you cut it in a section, let's say this is the circle. Actually, I can draw a better circle than this now, just for the beginning. This one, let's say this is the section of a helix, right? And let's say that this is our deck, okay? So the black one is going to be the section of a helix, and what you will get, what we have, or what we want, is actually the smaller helix will have to be cut in half, and that where it's being cut in half is actually where the deck is. So you can imagine the outer helix being like, it will cross here, it will go up there, and it will go down, and this is what it should be if you were to draw the inner helix with a diameter, or actually with a radius of 4.7. Okay, but since they have to be both helices have to be connected, or they're joined together on the bottom, which means that you can only take half of that circle. And this circle is if you put 4.7, it doesn't touches this point where we expect, which is this point where we expect the two helix to sort of come together. As you can see, here is where they come together. So basically these two horizontal tube binds those two together, is where they come together, both helices. And if you try to use this parameter, 9.4, the diameter, and then divided by 2, which is 4.7 as a radius, you will see that it will not touch that point that we mentioned. But obviously it needs to move down a bit because that's not where it should be. So if I try to, let me see, definitely need to move this down. Let's see if I can move. Actually, for this, we might need to take the lines from our I-beams, because that's where they all come together. So if I can just use curve and direct this away, doesn't matter if they're flattened. No, but I can give it a name. I can give this the name like I-beam lines, perhaps. And again, this is going to be one of the starting geometry that we will be using throughout our script also. So we're going to add that to this one should not be added to the group actually. I'm doing this wrong. Let's hide all this, copy that so that it still comes. So we are just going to be using this as a copy basically. So let's move that here. Okay, let's move that somewhere here and enable that. And let's try to get the center point CRV evaluation. From this one, reparameterize so that we can insert 0.5 as the middle point, rather than knowing the length of this and then dividing that length by 2. So this is an easy way for us to get a middle point of that. And now we need to know what are the distance between the center point of these circles and this point so that we can move them down accordingly. So if I were to move this, no, let's create a vector 2 point so we can use that instead. And I want to move from here to here. I don't know how that vector is going to look like, but let's just go ahead and move it first. And if it's wrong, we just have to flip these two together and then we'll get the other one. So, okay, so that's the one that we need. So if you zoom in, okay, let me disable this one. Oh wait, we're using render. I have to go back to shaded in order to be able to disable that. So if I enable back the lines, you will see that they actually don't touch. Okay, and that's going to create problem for us later on down the line because we expect them to touch. And that just comes down to the, let me show you. It just comes down to the radius for the inner helix is actually not 9.4. It's actually 9.35, etc., etc. So it is slightly smaller than what is being said. It could be that they just rounded it up and give you a good number to start with, which is very plausible. So what I mean by that is we cannot use 9.4 as a parameter for the inner helix anymore, but we have to use this number instead in order to make sure that there's no gap here. Because in the end, we will be using this gap. I mean, we will be using the intersection between all of the helices together. So we have to make sure that our data and our lines are joined properly in order to avoid any future problems that may arise that rely on the logic or rely on the assumption that everything is connected, everything touches, or as modeled as cleanly as possible. So what we're going to do, we're not going to use the radius of this, but instead we're going to use one of these numbers. Since they're all the same, it makes no sense to use them all. So we're just going to extract one number. You have to make sure that this is flattened, so whatever the case, whatever happens to the tree structure, we will always get one number. Even though I'm pretty sure that this will never change, but I mean, one click can make sure that this will always be good, so it makes no sense not do it, you know. Okay, so now we have that. What we're gonna do, we are actually going to bind this up here, and then we can disable the wire display because it no longer takes an input from here. And what that means for our this helix, basically we can delete it, but I'm gonna disable it for now. I'm pretty sure I won't be using it, but just to make sure that we know that we disabled that for a reason, I'm gonna leave it there for now. And maybe later down the line we can safely say, all right, this will never be used, so we can delete that. Okay. So with that said, we have our point with new diameter, and what you can see is they join properly, so it touches the circle. And what we can do now is we can see that everything comes from this move circle. So what we're going to do, we're going to hold down Control Shift. We're going to move all these inputs back here. Now this is going to give you an error because you have a cyclical process. But that doesn't matter because we know that this will come here and that will repair everything. Okay. And now as you can see, I can go back to render actually. The curve are at a position where they should be already. And let me see, so what we did is using this to move the seam to the bottom because our line points to the bottom. We flipped the curve because we wanted the circle to go one way. Now because we want the circle to go the other way, what we can do is ditch the flip and just use this one instead. We can delete that because we no longer need it flipped. We just need it flipped because in our picture, in our real bridge, this is the orientation of the major helix, not the other way around. That's why we use the flip. But since the inner helix is already at a good position, at a good orientation, we don't need to use that. So that is settled. So far so good, I would say. All of these actually. And only here there is a slight problem, but that has to do with the I think with the offsets. Let me go see if I can find out where it is. So this is our problem. This is the point that we used. Oh boy. You know what? Because I have Rhino is having a problem with my 3D mouse that I use. You can see the anchor here. It tries to find in geometry, but because Grasshopper geometry is not actually Rhino geometry, it doesn't really like that. So what I'm gonna do, just temporary, you don't need to do this, but you can if you want to. if you also use the mouse and have problem navigating. I want to bake one beam so that I have a real geometry to select and zoom to select it, so I can sort of reset the anchor point of my mouse. Okay, so with that being said, let's go back to fixing this. Let's see, how are the points ordered? I'm gonna do a point list, and I might want to do a tree branch and select the first branch instead of the whole thing. Simplify and starting at 0, so we have those selected, which is good. And go here, 1.1, so that I can select. Okay, obviously 1.1 is a lot bigger. I'm just gonna do something like this, so I can select more finely. Okay, what is the problem? Right. This is where I should go back to this. Remember that I counted these points before, okay? And I counted actually 13 sections, so 13 points, but 12 sections for the major helix that are above ground. Meaning, what I mean by section is actually like this, for example, is one section. Okay. If I can draw it on a separate photo, perhaps. This, for example, is one section. And I counted actually these poles, and those are 13. But because you don't count the last pole, we actually have 12 sections for inner helices before it goes from one point reaches to the other point. So let's see how we can incorporate that into the script that we have. Okay, so what we should now do is actually separate the top points with the bottom, because the bottom one are shouldn't be here, because the point should be following somewhere along that line, meaning the bottom half of the circles of the outer helix, not this part. So let's start our filtration process basically to separate these two and then recombine it again. And this will be how handy. One way to separate the points is to, I think, use distance in the z-axis to separate, because we want these points to be separated. We want to keep the top half of the point because we have 12 sections equaling to 13 points, so we need the top points. And let me see. Okay, let's do it like this. We're gonna use an evaluation command. Okay, and what the evaluation command allows us to do is we can insert a lot of expression in here that we're gonna be using to build a smart filter, basically, to allow us to filter all the points that we want. So what I'm gonna do is I'm gonna plug the point into X so that it has an input already. And if you want to know what kind of input that is, you can always go to right click on the F, expression editor. It's a point or a vector, meaning it will have an X, Y, Z value to it. What I can do is I can say, hey, judging from that middle point that we remember that we selected back down in the beginning of the script, you can say use that as an evaluation to see which points are below it, which point are above it, and give us only the point that are above the z-axis or above this point. That's the logic behind the method that we're going to be using. So let's grab our, we grabbed it here, but we can also just do this and just grab one point from here, which also works actually. So if you go in and see review. That's the point. One little thing is for the distance to work properly, what I usually like to do is, because we know that this point and that point is, oh wow, anyway, those 2 points are more or less in the same heights, okay? They're in the same z. So Rhino will have problem if they're very similar up to a certain degree because of the tolerances that that it has. So what I usually do to play it safe is I will move this point slightly down so that I can always say that point is always lower than these 2 points. So that's what I'm gonna do. I'm gonna move it down just a bit in the z-axis, of course. I'm gonna move it down by a minus 0.05 perhaps. Wait, is it down or is it up? Yeah, it's definitely down. Okay. And now I can actually, let's put that to y and let's put this to x. Okay. Now that we have that, let's start writing our expression. Actually, let's write our expression in a panel so that we can see what we've done there instead of going back to the expression editor in the F and see what we've done there. So what we want to do is say, okay, before we start, let me show you how to extract the z-axis very easily. You can always do deconstruct point. This one. This will give you the z-axis, the z value. But then you have to do this here and do that there, and then you plug in the z here, which works. But you can simplify that, or you can build, make it a bit more cleaner, let's say, by using expression editor to extract the z in the formula itself. I'm going to show you by using this. Just get this off the way. Let me do this instead in here. So if you were to say, because we know the input is called x, I have caps lock on, I probably shouldn't. X, if you put a dot, z, or x, or y, or z, you can actually extract that number, as you can see here. It's the same as the number if you were to go to deconstruct the point. It's the same number. So if you want to extract x, you just type x dot x. So that makes it a bit cleaner for us if you want to just extract the x without having to go through the whole deconstruct point, and well, you get the gist of it. So if you can say if, okay, the expression editor also takes in the if else commands, and how it works is basically if everything, the condition and the output is within the parentheses. No, these brackets actually, they're not called parentheses. So if, let's say, x dot z is bigger, okay, then the point from y dot z is bigger than the z value of y, comma, then if that is true, whatever we type here will be run. And since we want to use this as a calling pattern, we want to enter either true or zeros and one. It doesn't matter, but let's type true. So if you type true, meaning if this expression equals to true, then the results will be true. You can also say give me a number instead, which is fine. This is basically an output if the condition that we've defined here validates to true, returns true. So we can say if the z of x is bigger than the z of y, then it's true, otherwise it's false. And if you plug, okay, let me open this for you. So what we will expect to see is a lot of true false value if you plug this in here. And these are all the true false values that we can use in order to separate the top half from the bottom half by using a culling pattern. So if we use the culling pattern, the R goes to the culling pattern. The list we want to call are all the points. Okay, apparently we've called the wrong one, so we should. Okay, let's go back and see what we've done. And let me disable this because it's a bit. I should enable that one. So let's see what we've done. Okay, we've said if the z value of x is bigger than the z value of y, meaning if x is on top, if our middle point that we want to develop is on top of the points. Okay, let's say, okay, I'm sorry. Let's do that again. What this means is look at the z value, look at the height. If our test point, which is this point, is above these points, then it's true. Otherwise, it's false. And what culling pattern does with true value is it leaves it alone. When you put in a false, it will actually delete that. So observe what happened once I flip this. So with that, we've actually filter out the points that we need in order to build our curve. Now we're only missing the bottom half. And remember the bottom half actually lie within the same circle as the outer helices. So we can actually reuse that. We can actually copy this instead because we do need that. We do need the diameter of the outer helix. One thing that we don't need is we can actually use the same plane. You get. I want the points. Okay. That one can go for now. And we can actually apply the same knowledge, apply the same culling pattern here. So what we're gonna do is we're gonna just call, well, we have to copy that one, but the formula can be the same. Or we actually might just need to flip the pattern here, but we'll see what happens. So that one goes there. The pattern, the list modify. I expect to see the top points exactly. But since we just want to reverse the true and false, and we don't want to modify our central if-else command, if-else statement, we're just gonna come here, invert. What that does is it will reverse true to false, false to true, which gives us the opposite results, which is exactly what we need. So now that we have both points, where's that circle? Oh, here. So now that we have both points, what we can do is let's see how the ordering of these points are. So it goes from 0 to 12, which is exactly what we want because we want 12 sections. And let's see this one. I'm hoping it goes clockwise. And it does. Wow, cool. So now we can just merge them together with a merge command that comes from here and here. And this will go here. And let's see our results. 0 starts there all the way back to there. Perfect. And now we have to see what we're going to do with this. What's that? Those are the points. Maybe we can just plug that one in. I don't need the D3. Well, something might break. Oh, one thing we forgot to the culling, which goes all the way down here, which dictates how many points we want to delete. But of course, for the inner helices, this is less. because we have 5 helices instead of 6. So we might want to drop this down by 1, and there we have our helix back. So we still need to remove that one. Let's see, where does it go? The pattern? The pattern is the same, so that's not really an issue. Because in the end, we have 5, 2, so that's okay. We just need to find a way to remove that one, actually. I'm thinking one of the reversal has to be re-reversed, if you know what I mean. So let's see. We've reversed this here. We can unreverse that. Reverse that here. We can unreverse that. And oh wait, I think that's it. There we go. Oh wait, that point. This should actually connect here. So one of these points we are culling a bit too much. Let's see our culling pattern. How does that look like? No. This one, that one looks okay actually. Shift to modify curve. Remember that we use the shift to modify curve in order to shift the curve meaning shift the first curve that will be called the most. So let's come back here and identify how many shifts we should be doing. So before the shift, curve 1 is at the right place. So we need to shift this only once, not twice. So when you shift it once, and our starting curve will be on the top, which is exactly what we need. Something else is selected. Okay, let's remove that. And the second curve should be clockwise. Exactly. So we're moving 4 points instead. Okay, so that's correct. And this can go. So we shift that, meaning we checked that already. So this should be fine. And it is. It's just that our culling, for some reason that curve is not good. But anyway, we'll check on that later. Actually, let's disable. I cannot disable. It's on the render mode. But following our points, it looks alright. If you could just ignore. Okay, let's go back to shaded. Ah, damn! Accidentally did the wireframe. Okay, that's not gonna work. Oh, please don't crash. Okay, let's go back to this one instead. And now we can disable this. So our points is actually okay, right? And now we have to modify this shift. How does this look like? For the other end. I actually removed the the reversal process, but actually we need to keep those. I think I have one here and one here. Let's test that with this item. What's number 1? Number 1 is there. Okay. And how does it go? No, wait. Let's see where point 1 is. Okay. Point 1 is here, meaning the start has now been shifted back to where it was. But I want to see how is it going. Number 1, it goes counterclockwise. So we actually need to shift one back. But it has been re-reversed twice, so we need to watch out for that. This is number 1 now, or actually this is number 1. We might just need to shift. How does this go? Clockwise. So meaning this probably shift once, actually -1 maybe. Let's try 2 actually, and see what we end up with, because we want to have 3, so it is -1 because we have one less curve. Okay, so it is always -1 whatever the previous was. Okay, that looks okay, and we can get rid of this now for testing purposes. Let's check our new curve. That looks alright. That looks exactly what we want, except that our curve is now, like, it should be fixed now actually. If I go back to render and select that, I don't need to see the points. I just need to see our grid. That looks okay for one end, and the other end. The other end, please. There we go. Ah, fixed. So in the in the beginning, my apologies. We shouldn't remove a reversal. A reversal was actually for reversing the start with the end with the start, so that we can call the other end using the same pattern. Okay. I think I will end the video here. If you have any question or something's not clear to you, please don't hesitate to ask in the comment section. I will do my best to answer them. And in the next video, we're gonna be perhaps finish building the deck, which is not that hard. And we might move on from there. We might move on to the columns and the viewing pods. Basically these. It's gonna be fun to find a way to do this in the viewing pod, which is gonna be tied directly to the same probably points that we're gonna be using. So that's what we will try to tackle in the next video. Until then, see you in the next one.